we're going to graph quadratic functions by plotting points. I've set this up so you can see the steps. The first step is to graph the y-intercept, which is 0c. The second step is to graph the line of symmetry, which is x to equal minus b over 2a. We're getting these values for c, b, and a out of the standard form of the quadratic equation down here, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So in this particular example, we're going to get 0, negative 3, because that 3 is the c. So for the y-intercept, we're going to get 0, negative 3. But I want to finish what I'm doing over here. The third thing we're going to do is graph the vertex. Since the vertex is on the line of symmetry, it has an x value of negative b over 2a. The y value is the y value that we get when we plug this value for x back into the equation. We're going to get f of negative b over 2a. We're going to put that back into the equation. The fourth thing we're going to do is make a table. We need 5 values. Since we are graphing by plotting points, we need to have a table. The fifth thing we're going to do is determine whether our quadratic has a min or a max based on the value of a. If a is positive, it has a minimum at the y value of negative b over 2a, and it has a max. If a is less than 0, it has a maximum at f of negative b over 2a. Finally, we need domain and range. Let me fix that. At least I could do is spell it right. There we go. So using this equation, and I'm kind of rushing here, using this equation, we're going to graph this equation using these steps. So the first step is I need 0c, I need the y-intercept. I'm going to graph the y-intercept at 0. Let me change the color here. Negative 3. And 0, negative 3 on our graph is right. 0, negative 3 is down here if we get it right. There's 0, negative 3 right there. That's our y-intercept. 0, negative 3. Close this back up and make it right. We get that right there. The next thing we're going to do is graph the axis of symmetry. That is x is equal to negative, and I'm going to do this twice, it's negative b over 2a. I'm going to keep the colors. It's easier to do the colors if I try to bunch them up when I can. These I can bunch up when I can, so I'm bunching. Negative b over 2a. So over here we're going to get, for b, we're going to get negative 2, and that's going to go in parentheses when I bunch the colors up. I want A in red, so A in red, oops. A in red, that's going to be over here in red. A is 1. From this equation right here, our coefficient of x squared is 1, so A is 1, and we're going to multiply that 2 by that 1. So we get a times 1 over here, right there. Let's go back in and finish in black the way we ought to, so we can keep our colors working together here. There's an equal sign between those two. There's a negative. This negative right here that we're looking at is that negative right here. That negative 2 is b. If you look up here in this equation, that negative 2 is b, so we end up with a negative over a negative in the numerator. In the denominator, we have that 2. So this 1 is that coefficient right there. If you look down here, and you can see that a, this is the coefficient of 1. It's that 1 right there. That's the same 1 right there. It's not negative, it's times. That's a 2 right there. That 2 comes from the formula for the axis of symmetry. that negative right there is the same as that negative is the same as that negative. In this particular equation, negative 2 right here is b. So that shows you how we substitute all those correctly. When I get done with this, I believe I get a 1, x equal 1. X equal 1 is a line that we're going to draw. It's not going to let me move it. It's right in the way. So I'm just going to have to draw over the top of it right here. And I'm going to draw a dotted line, I hope. I don't think I'm going to. I'm getting a bunch of stuff on the screen I really don't want. I have no idea what this is. Go away. And I got to try to put this thing in here where I really can't see it. Right here. We're going to dot that line right there very, very badly is what we're going to do. Trying to work as quickly as I normally do. I've got a new pad. This is a new pad just for making these videos, and I'm still learning how to use it. Usually, look at this writing. You just seen this writing yesterday when I first started using it. So there's my line of symmetry. We know the vertex is on the line of symmetry. The next thing we're going to do is write our vertex. Our vertex is going to be at 1. If you look at that, that's negative b over 2a. It's exactly the same value as this, so our x value is 1. And then what we do is we plug that back in to this equation up right here. So when I do that, I get negative 1 squared. I get minus 2 times 1 minus 3. So my vertex is, if I've done this right, 1, negative 4. I hope I did this right. So my vertex is right down here. What we notice is we have symmetry. We put in the axis of symmetry. So there is a point that is equal distant from the line of symmetry as the y-intercept right here. So it's going to be over here at negative 3, 2. So I'm going to put that point. So now I've got 3 points on this parabola. So now we're going to make our table. And this isn't so bad. I get x, I get y. And what I do is I put the line of symmetry right in the middle. I put the vertex right in the middle is what I do. I put 1, I put negative 4. And then I move 2 integers to the right of the line of symmetry, which is going to be 2 and 3. I move 2 integers to the left of the line of symmetry, which is 0 and 1. Then I put these values. I put negative 1. I put 0, 1, 2, and 3. Into this equation and find the values. This really should be f of x right here. I'm going to put f of x equal to that y right there. And when I put these in, at 0 I get negative 3. I'm putting these values into this equation to see what comes out. When x is 0, this value is negative 3. When x is 2, this value is negative 3. When x is 3, the value of this thing is 0. When x is negative 1, the value of this thing is 0. So now I have 2 more points. I'm going to graph those points at negative 1, 0. I've already got that point. I've got that point. I've got negative 3, 0. I got 0, negative 3. That's 0, negative 3. That is 1, negative 4. That is 2, 3. And my last point from right here is 3, 0. I'm going to graph that right here. And I've got enough points that now I have some idea of what this thing looks like. And I usually graph parabolas in blue, so I'm going to graph this parabola in blue. So I'm going to graph that parabola right here in blue. Just like that. Oops, that is really bad. So let's see what I got here. Still learning to use this pad. That is really, really bad. But I've already passed this course, so I don't care. So that's what my parabola looks like. So that's the end of step 4. Step 5 is the value of A. Try and determine if it has a min or max. since A is greater than 0, I have a minimum at the vertex. The minimum at the vertex is -4, so I have a minimum at -4. So that's all of step 5. Step 6 is the domain. The domain, the domain for all of our quadratics is going to be all real numbers, and you can use what you want. I'm going to try to use that really bad Gothic R that I'm always trying to write, and I'm going to write it that way. It's all real numbers. Boy, that's really bad writing, but I don't care because I'm nearly done. The range on this thing is determined by all the values y can be. That's why we take the min, because what we need is y to be greater than or equal to -4 at all times. If you have any more questions, either review this video or come and find me.